System error. Shutting down.
Walk, don't run. Use the handrails. Walk, don't run. Use the handrails.
Neon Temple simulation reboot in progress. Live stream initiated. Stabilizing environment.
All right, welcome out to everybody here and online. We are here tonight to listen to the intro to reverse engineering. Okay, if you've ever come up on any CTF anywhere, there is always an RE channel. This is something people have asked about quite a bit. So tonight's Space Penguin's here to give us the rundown. So this should be a lot of fun, and if this is something that you are not familiar with, so I see almost everybody who should have a laptop with a laptop out. So that's a good thing.
I just got from work, man. I just got
How many people here just came from work?
No, dude, I just started up tired day.
All right. So coming up next week, anybody know, except for you, anybody know what's coming up next week?
Dr. Sunny.
Hell yeah, Dr. Sunny's coming. She's been doing some stuff that she wants to get some feedback on and run past a rough group of hooligans first. So we're excited to have her come out and present once again. And if anybody gives Dr. Sunny a hard time, you'll get thrashed by basically everybody. So, all right. So someone needs to go check the door and see who that is and if we're going to let them in or not. All right. After Dr. Sunny, the last one in the month is Rab, bringing chaos to coding security tools. All right. If you've ever worked with him or watched him build shit, I got to watch him a bunch of times at Cybercamp and watching him code stuff live. Man, it is a hell of a lot of fun. So you've all met him. You know what's coming. It'll be a good one.
Always entertaining.
So, if anybody has questions or concerns, you know where to find me. It looks like I know everybody here, so I don't have to chase anybody. That's all I got, and we're going to pass it off for tonight's presentation.
All right.
Cut right in front of me.
I don't know. I have an identity crisis. So for anybody who, I developed what we're going to talk about tonight as a hands-on thing, so I don't want to yip-yap a whole lot about this. I stored everything you'll need for this on this GitHub place here. So if you go to GitHub, SharkBite CS, you can find the reboot engineering thing up there, and I'll show you where everything's at. But first, I'm going to bore you to death because I just learned how to make a PowerPoint. So anyway, with this, who am I really, right? So it really doesn't matter who I am, right? I'm just some guy who likes tech like all the rest of you, okay? But I want to tell you a story which is far more interesting and compelling. 3 or 4 years ago, I don't remember which, after the pandemic, I went to DEF CON. I was excited because DEF CON came back. We were all down on lockup, right? The only workshop I could get into, and if anybody knows, they just did the workshops the other day, they all sold out in under 2 minutes. I snagged one again, thank goodness, because I'm ready on the fly. But After the pandemic, I went to the workshop. I couldn't get the ones I want, just like yesterday on the 15th. I got my 5th pick in line, which was reverse engineering. I said, well, you know, I'm primarily a software engineer by trade who likes to focus on secure tooling. So I said, we'll throw a hat in and see where it's at. So I took it. It was fun. I knew some of it. I learned a lot I was confused about. Came back, went to B-Sides Orlando, and they had a reverse engineering intro to Ghidra. And I was actually sitting next to one of our members in here, and I heard some people a row back or 2 rows back completely lost. They did not understand anything they saw in that, it was Ghidra, I think it was. And anyway, they didn't understand anything they saw. They had the output and everything else, and they were sad. And I was like, oh, that's interesting. Fast forward, I got prompted at a university I'm an adjunct at, and they said, hey, would you be interested in teaching this reverse engineering? Talk about following the prompts in life, right? Weird. So I said, yeah, sure, I'd be glad. So anyway, I taught that. So a lot of this is a compilation of what I've heard from people who want to get into reverse engineering, but completely lost on where to start and what to understand. Because IDA Pro, Ghidra, they're all really great tools, but if you don't have that foundation, you're missing it. So anyway, I don't know, almost looks like me. Yay for the AI stuff. All right, so before we begin, you got to have the disclaimer about don't hack stuff, right? Digital rights are really important. Video game people, I know a lot of people want to learn this so they can reverse engineer video game stuff. If you're doing it for the right reasons, that's cool. If not, stop, because they will come after you. All right, but the most important thing we have to understand is if you've ever started out with reverse engineering, even though we're talking about software reverse engineering, all of the hardware is going to drive and dictate everything you need to know, okay? So the computer architecture, if you ever took a class on computer architecture, it becomes very, very important, or if it's a hobby of yours. There's 2 theories out there that drive all of our modern computers. There's the von Neumann architecture and the Harvard architecture. So like the von Neumann one, right? A lot of our laptops and stuff use the von Neumann architecture. And your microcontrollers and such, your IoT devices, like I gave an example there of a temperature control gauge, like a thermostat or something, those are going to be your Harvard. Why that matters. Von Neumann, 1945. Aren't you glad that your laptop, this concept of the bus that you use, is from 1945? Think about that. It's almost 100 years old, and the architecture that drives the software that we have now is derived from this model. It's freaking incredible. It's awesome, right? So, but the bus of that shared memory, that's what von Neumann gave us. Tell me he wasn't ahead of his time in 1945, right? Especially when you think about what the technology was like then. But that's what's driving us, right? And this is going to be the gateway to our magic kingdom, where we start talking about how the processor and the RAM dictate the software and guide us in there. All right. So these levels of abstraction that we have, right? So when we write software today, right, we talked about the hardware. We said the chips are going to have us. I'm going to do some back and forth with this, and then we're going to get to the good stuff. But originally, right, we were doing hardware stuff. People were actually messing with tubes and everything else. And then we got to the point where we were writing assembly, hex code, machine code, right? And then we started writing Java and C++, Python, whatever you like, Rust if you're really cool and hip these days. And all of this is all dependent on the ISA, which gets into the really thing, right? Your ISA, this comes from your chipset manufacturer, right? This is going to determine kind of what your registers are and how everything communicates and all this. We're going to kind of I left a lot of this in the lab because I don't want this to be some kind of crazy heavy theory thing. I want to learn as you go. And I'll have these slide decks for anybody who wants this stuff available because it's all fun, right? But the things we're going to want to think about is like that RBP there, the base pointer, right? That's something we're going to see and we're going to talk about. That's really, really key to kind of finding out where things start for us when we look at this, okay? So the registers and the stack and the heap, right? All those pieces of memory become important. And remember, it's all going to be driven by the architecture that's determined by our chip manufacturer. So what we're going to do is I'm going to kind of, to give you guys an idea where I'm at here, I'm going to break out of this for a second, is in here, bring this over. I've got a lab book that's in here. It's a PDF. You can't miss it. But we're going to talk about Lab 1 here in a minute when we go back to the thing. I've included the source code, and I've included the assembly in case you get, because sometimes you can get some different assembly. We'll kind of talk about that a little bit. So there's some different assemblies. But what I want to do is I kind of want to stay true, and I want this to really be more hands-on for people to be able to see and do and not get bogged down in the theory. Because there's a lot that we could really get wrapped around the axle on, especially when we start talking about, you know, the pointers and the registries and what goes in there. When does a buffer overflow really occur? What that means. So we're gonna get there, but we're gonna go back to this real quick, right? So let's see. We talked about the architecture models, right? Von Neumann, the ISAs, right? The architecture, that how we have abstraction. Does anybody know what our next level of abstraction is? AI. Right? Everybody's like, oh, AI's taking developer jobs. How many people still program in assembly code as a job? Not many. So we're going to see prompt engineering or AI come in up here because it's going to write these mid-level second generation, third generation, fourth generation programming languages for us. And we're going to have a new level of abstraction kind of show up. So when you think about prompt engineering and vibe coding, we're just going to add one more thing. Everybody's worried about software engineers going away. Are they? No. I mean, did programming go away when we introduced like C or C++ or Java, Python, whatever language you like? Nope. It's just a new layer of abstraction. So watch prompt engineering. It's really important. All right. So let's do a walkthrough. I'll slow down now because, like I said, I don't want you to get bogged down in the theory yet. So we'll talk about the guide. I'm going to come back and re-talk about this and walk through the guide. But this first one, I make the assumption when I did this that nobody's ever written a line of code in their life. Or if they have, they've written one hello world. And that's basically what this is equivalent to. If you've ever taken a class in Python or anything else, right, in C++, you enter the main method. This makes it a little bit nicer compared to other languages when you're talking about reverse engineering because it's a defined starting point every single time. You know to look for the main method. Right? So keep that in your mind. Otherwise, int, right? Integers, variable names, links, right? And we're just calculating the area of a rectangle. So none of this should look too complicated or too hard. If it is, just take a programming class. This will become really clear, really quick, really easy. Don't want to spend too much time here. What I do want to talk about is in this class, one of the things I'd say is the G++ compiler is what I based everything off of. Right? Because remember, what does a compiler do? It takes that source code, translates it into something for the machine. So one of the things it's going to do is it's going to generate assembly. And I've heard people try to learn to program assembly. They look at the compiler output and they go, this doesn't make any sense. Remember, the compiler output is optimized for the hardware architecture based on what the compiler thinks is the optimal thing. So when you go to write like ASM or something like that, it's going to be different than what the compiler gives us because the job of the compiler is to do something efficient. So we could expect to see that later on with prompt engineering and the code it generates for whatever language you're having it doing for vibe coding kind of thing as we're calling it now. If you're using a MacBook or MSY2, that's what plays Cygwin or whatever it is, or if you're on any kind of Linux machine, you can just do an install for GCC, right? That'll give you the G++ compiler, okay? And that's all you'll need for that. And I know I got to get some feedback about the tools and installation for some of this because I know that I left that out, but as long as you got GCC, you'll be okay. So basically what you're going to want to do is you can run G++ to whatever that C++ code is, and that'll compile it, and you can run it, right? I don't know if I put it in here. I know it's in the guide. I guess we did run it here. And like this, I was on a Fedora instance here, but I ran it. It said the output was 50. I guess I had some hard-coded values in there. So, but the key is when you go to do this the first time, when we take our first steps, we want to throw in this -s flag. And the reason you want the -s flag is that tells it to generate the assembly from the compiler. Because the real magic happens here. So I want to walk through this first thing, and then we're going to walk through the lab book so you know how to use it and you can actually do this, right? So again, we mentioned all programs have a main method, right, for C++. So the first thing you always want to do is find that main method. Why? We know that's where things start. That's the thing we need to look for. This is the thing we need to figure out. When we look at all this assembly, you know, what we're going to want to do is we're going to want to look through here, and you can see this RSP and this RBP. This kind of tells us where we're starting at right here, right? This is going to be where we're setting the base pointer, right? So we're going to want to look, and this is going to C down. And then we're just going to read through this casually the first time, right? Because we don't know what we're looking at, and we've got to see all this. We're going to want to look for these move statements, right? These are going to be variable assignments. So like this first one here, we see move L 5, and it's an offset of 4 from that base pointer. So let's go back and look real quick. Well, we can see that we sent a variable to 5, right? And that, so because remember this is inside the main method, this makes this a local variable. So if you're not familiar with like what's a local versus global variable, this gets really important really quick because of where it gets stored, right? Local variables are going to get put on the stack, right? So we're going to know that from where we're starting, we're there. Any questions so far? I know I'm kind of blowing through this really kind of quick, but I want to get to the point where you guys hands-on keyboard because this is less interesting. But we're going to want to talk about how to find these, right? So we can see the 5 in here, the 10, and we can see the offsets from where they're at on the base pointer as the stack is growing, right? So we can see that. We can see the IMO, which was right. Anybody want to take a guess what that one is? Multiplication, right? And I heard somebody say it, right? Because that's our multiplication, which was right here. So we don't know what that is just yet, right? Because right now these are our first steps. We're just trying to understand some of these keys in the assembly. When you see a call statement, anytime you see a call statement, that's your output in C++. Remember, this is going to be a little bit language dependent too when you start doing these reverse engineering pieces. So, but if we know to look for moves, we know we have variables. We know we look for these IMOs, that's like, you know, your multiplication. Can a computer divide?
Does it divide or does it multiply by a negative exponent?
It divides by a fraction, okay, right? So your computer, right, doesn't know how to divide. If you say 2 divided by 4, right, then what you're really saying is 4 times 1/2, right? So it's just, can computers do subtraction? Or is it really just the adding of a negative number? It's not, right? Because you've got that higher math concept thinking. It's not. The computer can only do 2 things. It can add and multiply. And how it adds and multiplies is where things get fancy, right? So anyway, but the call, right? Call is output. And if you look a little further down here, you'll see there's like a move L with this here. And then there's a call that points back to that move L. And I just want to highlight this out, and then we're going to go look at the guide. Oops, I went too far. But you can see there's a call with some text, and we're going to look at how to read that. Read all this is like you go through this thing, and then there's an output there. So what all that tells you is, if you go back and look at this assembly, without really knowing how to read assembly or use any of the other tools, what this tells you is we've identified some variables. The variables, we saw some kind of math operation. That's interesting. We have output, and we have output of something that was from up higher, and if we look in there, right? But I don't want to get wrapped around that, as I said. So I want to go share. So the PDF, right, that's in here. This guy here, fancy PDF, not really. But I want to share with what I got in here because I think you'll find this more interesting. All right. So it's got a fancy cover in case you care. Oh, wow. Ooh. All right. Table of contents in case you get lost. So there's an introduction that talks about this. We talked about the legal and ethical of the digital rights, right? So please review that because that's really important because if you get, as you guys know, since everybody in here is like got that, I don't like the word hacker because I think it's kind of a weird word, but that mentality of wanting to be curious and explore things, especially through alternate means sometimes. Just be careful you don't get yourself arrested. Date night in the Iron Bar Motel is not what you think. Or maybe it is, I don't know. But understanding computer architecture, I can't point back to this enough, okay? I could do a talk if you guys want. We can pick some chipsets, and we can look at this later, but it gets really down in the weeds really quick. I try to stick with Intel where I can, because it's something I'm more familiar with. But I talk about that, and I even, take a moment and we talk about, we said the von Neumann architecture, which came from 1945. It brought us kind of that shared memory concept in a bus. Uh-oh, I gotta quit talking here. Uh-oh, ah. Well, that wasn't good. Oh, too much. So I got a section in here on talking about the memory and how these things grow, like the stack and the heap. And there's a section in here on these pointers. Like I said, you could spend a lot of time understanding these pointers and what they mean. And we talk about the different abstractions, which we've already talked about. And then I want to walk through this first one again here, because we add a little bit more detail in this workbook. So we've already, yes, sir. Yeah, if anybody gives me any feedback, I'll take any and all feedback. It sucks, it's great, I don't care. You're not going to hurt my single feeling that I have left in this world.
You're going to be using this as artifacts, right, for your program going forward?
This was something fun that I had, like, yeah, sure. I mean, it was fun. This was just something I did for fun. I got bored over a couple of weekends, and I thought this would be kind of cool to do something like this. So. No, this was just, as I mentioned, no, this was just fun. This was just, I needed something to blow some steam off and do something, and this is what I do.
This is the type of person that does stuff in their free time that gets it.
Yeah, so the code's in here, that's nice. We talked about what it looks like and then compiling it. But where this starts to get interesting is somewhere around here on step 4, right? Because this is where I started adding all this meat into this, right? So we've already seen, yep, there's the assembly. We know what it looks like. It's even in the GitLab in case you care to compare it, and you need to do it. But now what we do is we go through and we say, okay, we talked about these, what we're looking for, right? And that's really fun. That's interesting. And as we break down these instructions, we go through here, and it's like, why is this on the stack and not the heap? Does anybody remember? Local variable, right? So for any of you guys who are aspiring software engineers, are software engineers, that'll be your friend someday. Pointers, right? Because it's dynamically allocated. Everybody hears about the evil pointer, right? How many of you guys have read the thing that says the US government says C++ should be outlawed? And they say you should use a memory-safe language like Rust or Python or Java or .NET. Any of you guys know what that really means?
What?
Why is C++ insecure? It's really simple. C++ is governed by an ISO, or an international standard, that requires a ton of countries to agree on it. Currently, C++, the only language that is backwards compatible to version 11 from 1999. Could you imagine if Python or Visual Basic were required to maintain backwards compatibility to their early states in the late 90s? I bet they would have problems too. And so when the US government comes out and says, oh, we got to use memory safe, what they're really saying is the bureaucracy is tired of the bureaucracy. Right? I mean, it's really weird but true. So anyway, it's C++, especially the like version 23 that's coming out, has a lot of advanced features, but they're still hobbled by that ISO, right? So anyway, so this kind of goes down. I want to get to 2. So this talks about, like, I try to give steps in here along the way so that if you want to absorb what you're seeing and how you're seeing it, you can. But again, this is all just this one simple program that has a lot of explanations, and I don't like I said, I don't want to talk at you because people absorb in a different way. And doing it and looking at it and comparing the lines line by line will give you a lot more out of it. But I guarantee all of you guys will know that move L, because I've talked about this enough, is going to tell you. What was that -4? Does anybody remember? It was the what?
The offset.
The offset from the base pointer, right? And we talked about the base pointer up here if you want to go back, right? So you can come up here and you'll see where the old base pointer is, and then it starts building because the stack goes down, right? And talks about that and the other things. So this was kind of designed to get you that started so that when you go through this. Now I want to talk about Lab 2 real quick. Lab 2, I'll tell you the only thing that this lab teaches you that's different from 1 is the for loop and the if statement, right? Because how assembly handles those, here's a spoiler alert, they're called jump commands. So if you can understand these jump commands, they're really, really simple. Like here's one down here, it says JLE. Anybody want to take a guess what JLE is? 85 right here. So this says JLE.L5.
Jump loop.
So jump less than or equal, right? So you've heard of an if statement, right? So like in CMP will be compare, but I kind of put this in here because right now you want to have this ability to look at this code right here and translate the two so that you can understand kind of what's getting generated in there, right? So understanding these for loops and how you get like these jump statements that when you see JMP, that means jump, right? Think loop or potentially an if statement, one of the two. And as you read through these, it'll start to bring clarity. And then we'll talk through, see this will be your first look here. This starts getting into like how IDA Pro and Ghidra is gonna start kind of laying this stuff out for you. But we're not quite there yet. But when you get down to Lab 3, after you've mastered the basics of like move L, calls for output, jump, JLE, right? This kind of stuff, then you'll be good. Lab 3, I'm just going to give you a binary. At this point, you've got enough, we're going to tear it apart. And what we want to do with this is I use GDB for this. And if you guys aren't familiar with that, that's the GNU debugger. And just like if you guys are on a Mac, you can say brew install GCC. You can also do GDB. And this looks the debugger tool that you would use for C++. Now the kicker with this is you're going to go into GDB. I gave you the commands in there. We walk through this step by step. What we want to be able to do is disassemble this is what we're going to end up doing. And of course, because we're talking C++, where do we start in all C++ programs? Main. The main function every time, right? So that's why there's a little arrow there pointing you to the main. So because when you run this, because you're just going to get a binary on this third lab. It's just like, ta-da, here's an executable. What do you do with it, right? I don't know. It's an executable. And that's how these CTFs go. They just go, here's an executable. So you guys got 2 weeks to practice before DEF CON. I'll be in the reverse engineering CTF this year, so. No, I'm serious. It'll be a lot of fun. They have really easy ones to start with. They always do. So like you'll be able to put these skills to use if you spend a little bit of time just kind of going through and figure this out. But the key here is when you get handed that binary, what's the first thing you should do with any binary you're handed? Run it. Even if it's malware, run it. Just run it in a smart place, like a sandbox, right? Yeah, I mean, right? A little common sense. Well, I mean, you know, you can live on the edge and run it wherever, but you want to run it, see what it does, explore the behavior, take your notes. After that, get a debugger hooked up to it. Step through it, get it to run. And that's what we do here, right? So the first thing I did is I said, hey, you know, let's go ahead and, in this case, I listed all the functions first. I said, hey, show me all the functions in this code, right? For any of you guys who are Java or Python, you might know them as methods, right? Or maybe Python calls them functions, I don't remember. But you're going to want to look for those, right? Because that's going to give you the organization of what your code looks like at a high level, right? So you're trying to figure out what this thing is. You've ran it, you've made some notes, and the first thing you want to do when you get it is you say, oh, well, shoot, I've got this thing. let's see what it's structured like, right? We know it starts in a main, and then it's going to do some stuff, but if you see other things, you know they're going to get called. And if you're doing this for your, like, doing security research and you want to find that CVE out there that's exciting to you, you try to find the methods that aren't called and how to exploit those and find that dead code that does something bad or it shouldn't be doing. And then you're a winner. So anyway, this talks about how to get into GDB. We can run the disassembler when we say disassemble, and ta-da, it produces the same thing as that -S flag we were already used to looking at when we were kind of crunched our way up, right? So we were initially looking at this and we were like, hey, you know, I've got code, I know it does this, but we're gonna kind of walk through this and try to figure this out, right? So we already see a move L, but I know this is kind of small to read, but it says $0x2a. What do you guys think that is? Hexadecimal, correct, right? So it's hexadecimal. So we might want to run that through a hex editor to figure out what the heck that even is, right? So a hex editor comes in really handy for this stuff because you got to remember we're putting a puzzle together, so we don't have a lot of good information, and we're going through. Just like here, there's a call. We can see the memory location of this call of what it's putting in there, which was just from right above it. So we can kind of get a feel for all this that's going on. And then I left you guys lots of notes so you can understand what the values of these are. Like we talked about this here. One of Tremere's favorite numbers whenever he gambles. He's always like, black 42, right? Nobody called me on that. Roulette wheel stops at 36. But yeah.
I wasn't going to say anything.
So anyway, so this kind of walks you through those step by step using that debugger, right? So if you have any questions about this, reach out to me on Discord, right, or anything else. Like I said, I don't want to yap at you guys a whole lot. And then there's a 3A and a 3B in here somewhere. Talk about things like object dump, which does some of the same things that the GDB debugger does. One of the things I'd recommend is always running strings as well on there. I'll give you a little spoiler alert for this, but when you do lab 3B, if it says your favorite number is in here and stuff, you should look, because sometimes you find things like hard-coded passwords and such. Just by running a simple string, you're like, well, this is interesting, you know? And you're like, why am I getting this? What is this test 1, 2, 3? And you go, I wonder what this means. And anyway.
Don't pretend you know something. Strings will get you really far.
It will. It will. It'll give you a lot of information. But remember, you're going to want to keep good notes. I don't know if you guys use like Obsidian or something else for your notes, but you're going to want to keep really good notes, just like if you're doing any other kind of CTF or whatever. And I hope some of you guys will be out there at the reverse engineering thing they're going to do at DEF CON this year. They're doing one. It's supposed to be pretty good. It's a new one this year. And there's also a couple of schools that put one up. I don't have anything else to yap about tonight on this, because like I said, this is a really good hands-on thing if you guys want to work through this and see it. I'm here to help if you need anything, but I think hands-on keyboard's the best way to learn personally.
All right, who's lost so far?
You put the GitLab back up there for everybody, and also post that on Discord so we can go through that.
Yeah, I'll put it out on Discord.
We're getting through it. That was the GitLab. Well, it's very well done. You did a good job on this.
So
So, for those of you who are saying you were lost, this is probably one of the best intro to CEs write-ups you could get. Right? It starts with a little bit of everything you need to know. Every other intro I've seen jumps in assuming you know all about the pointers, know all that other stuff. It's just talking about how to do the tools. So I would strongly recommend for everybody who has their hand in the air and hasn't done this to walk through this. Again, every single CTF you're ever going to do is going to have an RE section. You need to understand this kind of stuff before you start playing with Hydra or Hydra or whatever. Because if you don't understand this, you're going to be playing with a tool that's giving you output that you don't understand.
if you want to have some real fun, take your favorite binary. I don't know, maybe it's Excel, maybe it's Adobe, one of the Adobe Creative Suite ones. Start reversing it.
Is there anybody who's lost that has like not seen it, the programming that he's done so far in any language? People who wrote their everybody's programmed before? You've never seen that code? Okay.
The original block that he had.
Yeah.
Hey, Mark.
Oh, wait, no, the original
Mark.
one.
The original block where he was pointing out the,
C++ code.
that one right there.
Yeah.
Hey, Mark.
Yeah.
We got a question from online. Any legal or permission-related things to consider before reverse engineering other things that are out there?
Right, so there's kind of a neat little thing, like DCMA rights are really huge, right? So unless you explicitly have like the approval to do this, be very careful. Like if you want to tear apart like a Windows binary on your machine because you're curious how it works, that's okay, right? Nobody's gonna fault you for exploring what's on your machine.
Yeah.
If you want to do security research because you think something's out there, that's okay too. There's provisions out there. It's kind of like Good Samaritan laws.
Yeah.
But if you're doing it to like circumvent something or do something malicious, obviously that gets to be a bit of a headache.
Get the upgraded version, whatever.
Yeah, to get the, yeah. So you definitely don't want to just do it to do it, but you know, if you're curious and you want to know how something works, it's really exciting to kind of take this stuff and figure it out, because when you can put something back together, even if you only got like bits and pieces of it, you can figure out between running it. That's how malware analysis is done, right? So somebody puts out malware, easy peasy.
So one thing here, unless you own the software, you still have to abide by the licenses or the end user agreements that you agree to. It is illegal to RE a lot of stuff that you don't have permission to use.
Yep.
So for directly answering the question that we had, no, you are not allowed to RE whatever you want. That being said, everything he said is generally true. I have seen people get bit if you're trying to write a paper for school. You are admitting to breaking the law when you turn in that paper. If you're writing blogs about stuff online, I've seen people get visited by the people in 3-letter coats. I might have been one of them. So, just like anything else, we're not out to weaponize anybody, but if you're doing it ethically and responsibly, that is one thing. You can avoid a lot of legal hassle if you're reporting things ethically. If you try to report something and they say you are not allowed to do that, then the only legal recourse you have is to drop everything and don't play with it. Right. So be aware there are legal issues here. That's why we started out with our own little program, which we're allowed to RE, right?
Yep.
So be aware of that.
And even the ones we put up, right? It's all about fun, and you know, once you understand some of the basics of this, right, and you've got a clue of like kind of what the assembly is, whatever language you're playing with. I happen to just pick C++ because it's an easy one to start with, believe it or not, because it's so well defined. Go grab an open source library, right? And then you can start kind of figuring things out. Because remember, you can run things differently in different ways, right? So, yes, sir.
I know you're starting with the C++ with no libraries. Where do you put ltrace, strace commands utilization in there? And then, like, I know you're using an x86-64 instead of an ELF, like readelf, for getting outputs to understand where your jump codes and where your breaks are for breaking down your source.
Right, and what's your question?
Where do you use that? What do you use that for? ltrace, strace?
Oh, I'm not sure. I'm not a reverse engineer person.
Okay.
I just started doing this for fun because I heard about a gap, right? So what I saw is that a lot of people wanted to get into reverse engineering, and they were like, where do I get started? I don't do this for a living at all. So unfortunately, I'm just a web app pen tester by day. So that's why I make my bread and butter these days. So, you know,
as far as the object dumping and disassembly, which is one of the phrases you would use to make that, like for buffer overflow or for routing or finding canaries through there.
Yep. I had on ELF on here somewhere. I just saw it. So, you know, by no means am I an expert on this. I just keep going past it. It's first time ever using a computer. So, man. Let's just see if I can figure out where it's. I think it's down here. Because I saw the ELF commands and stuff in here that you were talking about. Might be up here, but I'm not sure where. But I pulled something in here on this stuff. You know, I don't. This is just a hobby for me, and I literally just wanted to share out what I could figure out with this stuff. This is something I started a couple of years ago, and I just been having fun doing CTFs with this. I would never want to be a reverse engineer person for real. I think I would lose my mind. I mean, I know a lot of assembly now, more than I took an assembly, right? I'm older, right? I took assembly as part of my computer science degree, and I thought, thank God I made it out of that. I'll never see this again, and I don't know, full circle in my life. But anyway, it's just here to, you know, if you guys want to learn more about this stuff, you know, by no means am I a super expert on any of this, so I don't know where to put some of those commands, like you're talking about like the local set and all that kind of stuff. I don't know where they go, especially in those tools and such.
And then the variables, like the RDP variations between x86 and x64, those are very different.
So they're not, right? So that's actually a little bit of a misnomer. Let me see if I can get up there. So it's between the x84. It'll be different between like the other chips, right? But let me go way up here for your question. Way up here, way up here. So when we talk about the information structure set, I got a place in here where we talk about, the different, where are they at? Here they are, right? So these just get renamed with a slightly different letter in front of them, right, between the two, and that's it. I mean, and there's a few more of them for the 64 versus the 32, right? So for like your general ones, there's just going to be a little bit more of them. But that's not going to really, this isn't going to focus on those ISAs, right, in the registers. We're going to see some manipulation in here, but this entry level is not focused on the registers and how to manipulate those registers, right? That's like a whole other thing, and that starts getting a little bit beyond like where I'm at with this stuff.
Yeah.
But a lot of times, if you go look between the like you said, the 32-bit and the 64-bit, there's just a few more of the general ones that are numbered, and then the letters change a little bit.
Because a lot of CTFs like to trip you up, as you said, because you just get an ELF or an EXE.
Mm-hmm.
They don't tell you what architecture it is or what ISA it is.
Nope.
And if you're trying to find a RAX instead of an RDX, you're going to totally be lost on trying to find the flag.
Yep. Well, this is to get you started with all that, right? Because so many people I hear, they're like, I don't even know what to do with this. Right? So where do you start, right? You got to run it. You got to disassemble it. You got to look at what the functions are in there. And then when you do that, you're good.
If you're doing any CTFs in Black Hat or DEF CON and you don't know what you're doing, do not just run the executable.
This was not at Hacker Summer Camp at all. This was at actually a completely different CTF, but I didn't. And the rules specifically told me don't run this on your main machine. I looked at it and I said, you wouldn't give me something bad to put on a CTF, especially one for beginners. What? That thing goes in and proceeds to change all my registry keys and fucked it up to the point where I had to do a clean install of Windows and lost half of my shit. Yeah, no, I was like, damn it.
That was a nice one.
Oh, it was very polite. Compared to what I heard from other people, very polite.
Yeah, always run it in a sandbox.
What is stupid?
Anyway, have fun. Reverse engineer your life away.
If you get good at it, it's easy points in most CTFs, because most people run away from it. Really.
This is really easy to get into.
Yeah, you good.
Oh, it was just designed for somebody to sit down and play. Hey. Here's your fancy mic, sir.
Thanks, man.
Perfect.
So as Crypto was alluding to, RE is something that is very easy to start with and very hard to get really good at.
Do you want to, we can leave the stream running if you want to ask a question, or we can cut it off and just like it work.
So for those of you on the stream, do you want us to leave the stream running while people are playing here, or are we just going to cut it off? You tell us. I'm talking to the people on the stream.
Give them a second. It'll it'll delay.
RJ's gonna get on the screen.
Oh, RJ wants to move around.
The system there, create a file on that story and put it onto your computer.
Yeah, we can cut it. I think. Does everybody have the slides or like the stuff? Or?
So all the stuff is online and it's been posted.
Yeah, we could probably cut it and we'll just hang out.
All right, folks. We're out for now. If you have questions, let us know or ping Space Penguin online.
I've never done this before.